Yes, we have had great five great talks from great speakers. This last part, the data set and challenge, which we had to discuss in like an hour ago, is left for the last, and I'll continue with that, and then we'll have the closing remarks afterwards. So yes, it was supposed to start at 11. We all know that autonomous agents perceive the world around them and take actions. Reasoning over the visual data is desirable capability for them, and that enables them to forecast the next events or actions in the video. Observing this pass, it's very crucial for them to anticipate what happens next to navigate safely and smoothly. Anticipating the future is a simple yet useful piece of information that helps agents decide what action to take before it is late. One way to anticipate the future is to directly predict the pixel values of the future. However, it's costly and often inefficient. So video prediction, pixel prediction is one of the ways to do the prediction, and this defines one level in the abstraction level. We have one other way is to predict the semantic segmentation, semantics in the future, which there are several publications in this field. So defining another level in the hierarchical levels of abstraction. So although forecasting the scene semantics can provide the agent with detailed configuration of the scene formation in the future, in some cases to make decisions, precise trajectories or body part movements are of greater interest. Therefore, prediction of individual trajectories and detailed trajectory, detailed pose movements are of great interest, which define another level in the hierarchy that I'm defining, trajectory and pose forecasting. The detailed trajectory and pose forecasting defining another level in the hierarchy. A higher level can also be defined by predicting future actions or intentions of the individuals in the scene. For example, in this example, if they do have the intention to cross the street or not, which will define this hierarchical structure. So with this definition of levels of abstraction, there are several works in each of these topics. We've published several works also as well, but this trajectory and pose forecasting component topic can be of great interest in many applications, including robotics, human-computer interaction, healthcare, and many others. So with that, this was one of the major reasons that we put together this challenge and benchmark. We observed that many of the previous works often work in the local space, like removing the global trajectory and movements of the pose, and therefore they only predict the movements in the local 3D space. While there are several works in the trajectory prediction field, while these two are highly correlated. So there are various real-world challenges when we want to solve these two problems together, which are mainly ignored by many previous works. Utilizing information about different levels of human to human interaction or human to object interaction is essential for understanding human behaviors. However, movements of all persons in the scene are not only highly correlated with each other, nor the humans to objects, which is important to be discovered by the models. So this defines a problem statement of observing the past sequence of movements or body pose and trajectory, and then predicting the future, most probable future. We talked a little bit about the multimodal works as well, either predicting the most probable future or predicting the probability distribution over the future. The goal of our challenge and benchmark was to solve this problem in a joint fashion, and therefore we created a unified training and evaluation setup for this interesting problem of predicting future human trajectory and skeleton pose dynamics jointly. So this was a new benchmark data set and challenge with extensive evaluation system, which, which basically was possible by using two public data sets. We also thank 3DPW and PostTrack dataset providers. The details and information are also included on the website. But what we did was basically using these data sets, we created the training, testing, validation setup for predicting human movements and dynamics in 3D from 3D poses, and also in PostTrack with 2D poses in the image coordinate. So both of these data sets define their own challenges. PostTrack has lots of global and local motion, and includes a lot of invisible joints, which was part of the benchmark evaluation metric. So we first looked at this VIM metric, visibility ignored metric, which is the traditional MP JPE metric that is used by the previous works in the literature. But we also introduced a visibility aware metric here, which was inspired by a set distance operation metric. So it penalizes predicted invisible joints. And we also had a visibility score metric that evaluated the trustworthiness of the predictions. So probably you all know that we proposed a tripod baseline to this benchmark, and task by using the information by creating like graph between humans in the scene, and building on top of that an LSTM, a recurrent neural network, then building the interaction graph between humans and objects, which at the end was concatenated. The features were concatenated with the spatial temporal scene features. And at the end, in the future, we also include graph interaction graph between the humans in the scene. I don't want to spend time on this model very much. The video and the paper are presented in the main conference. We evaluated the method by comparing it with some methods that are doing disjoint local and global predictions. And then our method, the ones that are jointly implemented, they work better than the other methods. Although we mentioned this was, and the question was asked in the chat, and also we mentioned in the response that although we are getting the best results compared to the disjoint methods, this was a very first trial on this benchmark, and the results are slightly off compared to an easy, naive baseline of zero velocity. So this showed that this definitely required more work, and as shown by the challenge participants, we are having, and these were presented in the earlier in the workshop challenge. I'm not going to repeat them again, but as shown by the winners, using social and scene cues can still help and improve the results. So with this benchmark, we also looked at many qualitative results. Again, I think it's best to use the time wisely. So as the conclusion, I would like to say this, as again, this was a simple starting point for this benchmark. I think we have two great data sets now that methods are being built on, and results are improving drastically over the past 3-4 months. We've got great results. We are hoping to continue this direction in the next year. This work, we will add more data sets, more challenging tasks, and hopefully greater participation by all of you guys, and we will continue this direction. So let me do the closing remarks as well, and if there is any question, I'll hope to answer them afterwards. I would like to thank all of our organizers, co-organizers from different universities, Stanford, from Monash University, University of Toronto, and I would like to also thank our amazing speakers. I think we had 5 very nice and diverse topics covered in this half a day workshop. I would also like to thank you, everybody, for being here with us. If there's any question afterwards, you can also find me and other organizers online via email.